All right, our next speaker is Amanda Munro. Amanda has 5 years of experience in the conservation world, organizing with environmental groups, social justice organizations, and legislators to bring about progressive policy change. Throughout this program, she has been bolstering her data science skills so she can pursue her childhood dream of becoming an ornithologist. After graduation, she hopes to continue providing the scientific analysis needed for smart policy making in order to create a better future for animals and people alike. Something I've really appreciated about Amanda during the course of this program is her openness and her just proactive communication and her vulnerability in just reaching out and wanting to talk through challenges as they arise. It's something that I think is important when it comes to doing, sort of passion-driven, mission-driven work. And it's something I've really appreciated about her time in the program. She also creates a very safe space on Zoom for barking dogs, which I appreciate a lot because I now have a barking dog. And so that has been kind of a delight as well, to just have our dogs sort of bark at each other on Zoom when we have meetings to talk about our feelings and challenges. So today, Amanda will be talking to us about climate impacts on breeding success of Laysan Albatross on Midway Atoll.
This is Wisdom. She is the world's oldest known wild bird at 70 years old. Just last year, she successfully raised a chick with her partner of 10 years. Wisdom is a moli, which is the Hawaiian name for the Laysan albatross. She travels for thousands of miles every year, only to return every year to Midway during the breeding season to reunite with her mate. Moli mate for life and raise a maximum of 1 chick per year. Once a chick has fledged, it typically takes 7 to 9 years before it will find its own mate and reproduce. This relatively slow life history makes every chick important for the species' ongoing survival. However, reproductive success appears to be going down in some colonies. This is a graph that I made using the data from Midway Atoll, Wisdom's colony. It plots years on the horizontal axis and reproductive success on the vertical axis. I calculated this by dividing the number of chicks that successfully fledged by the number of total nests in a given year. At first glance, reproductive success appears to be trending down. Resource managers on Midway Atoll are not certain why this is happening, but told me that they suspect rising temperatures and more intense storms could be playing a part. I wanted to look at some of the climate variables that could be contributing to this reproductive decline for more reasons than one. Yes, moli are charismatic species, and I am totally in love with them. But also, moli can help us understand broader biological patterns taking place in the Pacific. Because moli are large seabirds that return to the same breeding colonies every year, we can easily observe them. They are also top predators, so if something is wrong farther down in the food web, they will likely be affected by it. Moli traverse large distances, sometimes hundreds of miles in a single day, so they are representative of species throughout the Pacific Ocean. This combination of traits makes moli sentinel species for climate change. Climate change is rapidly altering marine ecosystems in ways that are difficult to observe directly. Like a canary in a coal mine, a sentinel species is one that we can easily observe and that responds to changes in the environment that we might otherwise miss. Studying these birds and their responses to climate variables will not only help us to understand how to protect them, but also how the pelagic Pacific ecosystem as a whole is responding to a changing climate. While there are other factors that could be contributing to the reproductive decline on Midway, I chose to focus on climate variables for this project because of this albatross's role as a sentinel species in the Pacific Ocean. The goals of this project were first, to understand some of the climate-related factors associated with the reduction in reproductive success, to shed more light on the ecological complexity of climate change impacts in the Pacific Ocean, and third, to provide management suggestions so birds like Wisdom can successfully raise chicks well into the future. In order to meet these goals, these were the steps that I took. Today, I'll be telling you about the 3 local variables I analyzed, including heat, rainfall, and wind speed. I'll also talk about the two basin scale variables I looked at, ENSO and NPGO. Then I will explain the statistical models I used, what my results were, and next steps. Midway Atoll is located within the Papahanaumokuakea Marine National Monument, northwest of Hawaii. It is home to Wisdom and the largest colony of moli on Earth. Over 1 million albatross nest there every year. From 2005 to 2021, the U.S. Fish and Wildlife Service collected data on reproductive success from 2 plots on Midway Atoll. They counted how many eggs were laid that year, how many chicks hatched, and how many chicks successfully fledged. Once I received these data from the agency, I began my analysis by collecting and summarizing data on local and basin scale climate variables. I gathered local climate data from the Midway Airport. This airport takes climate readings every few minutes, so I summarized these data to create a new comprehensive data set using the programming language R. I filtered all of the data to only include values during the breeding season from November to July. The first variable I analyzed was air temperature on the island itself. It's documented in the literature that albatross chicks on Midway have died from dehydration associated with heat stress. I hypothesized that high temperatures would be associated with low reproductive success. For this, I calculated both average daytime air temperatures and extreme ones, thinking that even one really hot day or an increase in hot days could kill chicks. The second variable I looked at was rainfall. It's well documented that flooding events can kill chicks and adults. Like air temperature, I calculated average rainfall data as well as the number of extreme rainfall days. I hypothesized that higher rainfall or an increase in rainy days would be a predictor of lower reproductive success. The third local variable I looked at was wind speed, thinking that stagnant air could make it difficult for birds to cool off in elevated temperatures. Also, wind speed is really important for moli flight. Because of their large body size, they rely on wind to get off the ground and forage efficiently. For these reasons, I hypothesized that higher wind speeds would have a positive relationship with reproductive success. Next, I wanted to look at basin scale variables. The first one was the El Niño Southern Oscillation Index, or ENSO. This is a naturally occurring climate pattern that affects weather and rain patterns worldwide. El Niño and La Niña create extreme conditions that affect the ecosystem in a variety of ways. For example, La Niña is typically associated with heavier rainfall, cooler waters, and stronger winds near Midway. Previous papers focusing on other breeding colonies have shown that albatross reproductive success declines during La Niña years, so I hypothesized that this would be true for Midway as well. But ENSO is not the only climate pattern that matters. The North Pacific Gyre Oscillation, or NPGO, is characterized by 2 gyres, the Alaskan gyre to the north and the subtropical gyre to the south. These gyres are separated by the North Pacific Current, shown by the white arrow. The NPGO index measures the strength of this gyre scale circulation, which varies both seasonally and annually. The NPGO is correlated with biological fluctuations in the North Pacific, like phytoplankton concentrations. This is important because phytoplankton make up the base of the marine food web. Where phytoplankton concentration is high, there's also likely a high concentration of animals that feed on them and the animals that feed on those animals. This includes moli, top predators that feed on squid and fish eggs near the ocean surface. The NPGO index is associated with the position of an area of high primary productivity, which is shown with the green plus signs. This is a favored foraging spot of some Hawaiian albatross species. Previous papers on nearby islands have shown that a positive or expanded NPGO is associated with lower reproductive success. I hypothesized that this would also be true on Midway. To analyze these variables alongside reproductive success, I ran generalized linear models. What these models do is they take a predictor variable, in this case my climate data, and plot it against a response variable, which would be the reproductive success data. So for example, a linear regression could tell us what is the change we expect to see in reproductive success for each degree of temperature change. When I ran these models just using the local variables, this was the model that was the best fit for the data. Reproductive success is on the vertical axes, and the predictor variables are on the horizontal axes. It included average temperature, high temperature days, average rainfall, and high rainfall days. although only the variables with the red asterisk came out as significant. Average temperature and average rainfall do have a negative association with a slightly larger impact due to rainfall. However, when I added global climate variables to the equation, the most important variable turned out to be the North Pacific Gyre Oscillation Index. In this analysis, an expanded NPGO was associated with higher reproductive success on Midway. This was also true in models that included local climate variables, like temperature and wind speed. This is really interesting because previous studies conducted on nearby Tern Island showed the opposite. They found that an expanded NPGO was associated with lower reproductive success. Researchers hypothesized that when the NPGO is expanded, this primary productivity zone that I mentioned moves farther north. This forces Molly parents to forage farther and farther from their breeding colonies. Normally, this wouldn't be an issue, but during certain parts of the breeding season, the small and fast-growing chick needs to be fed every couple days. These longer foraging trips could mean parents are unable to feed their chicks often enough during crucial periods. This is a rough animation I made to explain this, so if you can just focus on the green stars, which represent this high primary productivity area, that should play. This is a negative NPGO and a positive NPGO. Negative, positive. So a positive NPGO is associated with this high primary productivity area moving north. But my analysis is showing that reproductive success actually goes up with an expanded NPGO. So it could be that Midway birds are not foraging in the same places as birds from Tern Island. Or maybe they are foraging in the same place, but because Midway is 750 miles away from Tern Island, maybe a northward displacement of these foraging grounds isn't as big of a deal for Midway birds. The first takeaway from this is that direct climate impacts are important. If we just focus on the local variables, high heat and rainfall do seem to have negative associations with reproductive success. As part of this project, I'm presenting my findings to the Albatross team at U.S. Fish and Wildlife Service and providing management suggestions. What that might look like is providing more shade for the birds or removing impermeable surfaces that make flooding worse. However, local impacts like overheating and flooding are not as much of a concern as these basin scale environmental conditions that are affecting foraging. Variables like the NPGO deserve further study and consideration and should be included in status assessments. That being said, ecology is really complex. In this analysis, I got a completely different result than what I expected. In science, we can run across unpredictable complexities, and the purpose of doing this work is so we can understand these better. Why do Midway birds seem to have a completely different relationship with the NPGO than Tern Island birds? We don't know yet. Also, my R-squared values were around 0.34, so the variables I analyzed don't account for all of the variability in the data, and there are likely other factors at play. I plan to continue this research post-graduation, and I'm working towards a publication, and I hope that further study will shed more light on some of this complexity. Finally, this doesn't just affect albatross, but the entire pelagic food web. Like I discussed at the beginning of this presentation, if molly are affected by climate-induced changes in foraging conditions, it's likely that other species are as well. Ocean temperatures are rising, and in turn, there's changing ocean currents and the winds that drive these basin scale indices, like the NPGO. The NPGO was once a reliable indicator of fish stocks, but climate change is disrupting that. This is a global issue, and to address it, we need to take a global perspective and push for global policy solutions. Not just for our wisdom and her colony, but for all of the species that they and we rely on. I'd like to thank my all-star committee members, Davi Kasev, Rob Surian, Annette Henry, and Roberta Swift. They have been such an amazing support system from the beginning, and I cannot thank them enough. I also want to thank this program for giving me the opportunity to pursue the project of my dreams, and the U.S. Fish and Wildlife Service and National Oceanic and Atmospheric Administration for sharing data with me, to Samantha and Mark and Greg and everyone in this program for supporting me. So thank you, and I will open it up now for questions.
Wonderful presentation. I also love albatross. Maybe this is not as related directly to your project, but I was wondering if you had come across variables with plastic ingestion, because I know that's a big issue with albatross in the northern Pacific Gyre. And over the past few years, that's been a really big concern. So I'm wondering if that was something that you had considered when selecting your variables, or kind of how you went about that.
Yeah, absolutely. Great question. Plastic ingestion is a huge problem for these birds, and that's pretty well documented. I decided to look at there are other factors that are affecting the mole. One of them is plastic ingestion. Another one is bycatch is a really big one. But I was choosing to look at these climate variables because that is what the resource managers on the atoll were saying that they thought was potentially playing the biggest part. And also, like I said, about these birds being sentinel species and being able to alert us to changes happening within the ecosystem. I thought it would be important to focus on that. But I think further research on plastic is really important, and I would love to do that as well.
Thanks. Really interesting. I was curious about variance. So reproductive success is going down. What do we know about the variability, and is there anything that we sort of as humans can do to kind of intervene in that variability beyond, I guess, sort of the obvious of trying to slow down large-scale, more slow-moving climate damages, but is there anything kind of faster-moving that we can think about trying to adapt to or not?
Yeah, that's a really great question, and I'm planning to pursue this research post-graduation, and one of the things that I really want to look at is potentially dividing up the breeding season into significant phases, and then looking at time series models so that we could maybe get our better idea of like, okay, maybe there was a really high heat week and then we saw this number of chicks die off. So we have that temporal element. The GLMs does not account for time. So I think that's a super interesting question and definitely would love to pursue that.
Thanks, Amanda. So we do have a question that came from the web related to the question about plastics that Raquel asked. How are you able to discount other environmental variables such as consistently high concentrations of lead from leftover munitions, as well as excessive consumption of plastics that may affect the endocrine systems of these animals? Were these treated as constants based upon some measurable level of reproduction in the past?
That is a really good question from the web.
Anonymous.
Thank you, anonymous person, for that question. Well, so I'll be honest and say that I did not look at those variables or account for them. Unfortunately, this is just a 10-week project, and I chose to look at climate variables. I think those variables are super important, and again, would love to do further study on these birds and on this island. But all great questions. So many things we have left to know.
Great job, Amanda. I'm so proud of you. I had a question on your graph with the breeding success. It looked like in 2019 there was like complete breeding failure. And so I'm just wondering if you could speak to what were the environmental conditions during that year, and do you know if breeding failures were occurring on other islands?
That is a good question. 2019, I can't speak to the environmental conditions in that year in particular. I do want to just keep in mind that these are just the two plots, and there are, like I said, 1 million birds nesting. So I'm not sure if that was true for all of the plots or all of the birds on the island. I know that 2011 was a really bad year environmentally with, there was the tsunami that took out a lot of nests, but as far as 2019, I'm really not sure what could have caused that. But again, I think looking at the temporal element and bringing in like a time series model might shed a little more light on that.